Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.
Hello everyone, dear friends. Today we are delighted to present another insightful webinar. You are currently with AERONOVA, and I am Fedor, the esteemed technical director of the company. Today I'll be giving a comprehensive lecture. Let's once again carefully recall what exactly we're currently working on, what specific stage we're at in our development, and which particular devices we are actively developing. If you can hear and see everything clearly and without any issues, please show some activity so that dedicated technicians know everything is functioning perfectly. It's the middle of summer today. If you remember, we announced this project at the end of last summer. There's just a little time left. Our project is about to turn 1 year old. So we can do a preliminary summary of what we've accomplished over the year. That's exactly what we're going to do now. Yes, people are saying everything's truly great. Friends, once again, if you vividly remember, we embarked on an incredibly ambitious and challenging project to successfully revive a specific foundational technology that had perhaps been overlooked or underutilized, and then, building upon that very technology, to meticulously construct an entirely new and thriving industry around it. We're talking about aeronautics, about airships. The goal of the project is to build a sustainable system, a sustainable business within 5 years. This business will be engaged in development, design, launching into production, manufacturing, operation, commercial operation, and sales, as well as supporting future customers and scaling the business. The goals are quite ambitious. All of this is fundamentally based on airships. We have chosen a strategic approach, starting with a small airship and gradually increasing its size, making them more complex as we move to larger ones. This actually gave us a significant amount of insight, because those who attempt to develop a very large airship right away, we can certainly look at the global experience and learn from it. It turns out that building a truly large airship from the very beginning is an incredibly labor-intensive and exceptionally difficult undertaking, and any significant mistakes made at the very inception can lead to problematic issues many years later, thereby forcing you to significantly roll back your progress. The very first airship, which we had determined through extensive expert opinion, would undoubtedly be in high demand on the market, but without a truly clear market response yet, we ultimately chose to have a substantial volume of 2,000 cubic meters. This means that 2,000 cubic meters of helium are filled into this airship. Each cubic meter of helium lifts 1 kilogram, so that's a total of 2,000 kilograms of lifting force. Oh, 2,000? That's right, 2 tons, but minus the weight of the airship itself, and you're left with a useful payload of about 500 kilograms. Actually, right now, it's a bit more than that. This is the first airship in the lineup, and it's a non-rigid one. Airships are divided into non-rigid, semi-rigid, and rigid types. This means that the airship's hull, the largest part of it, is either made of a soft material or of the same soft material but with a small internal framework. The German Zeppelin airships are currently produced using this kind of design. There's a triangular truss inside and a soft envelope on the outside. The engines are mounted on the triangular truss. These are semi-rigid and rigid types. They're similar to those Zeppelins, like the Graf Zeppelin. In fact, there were a lot of rigid airships, almost 100 different kinds, even just from Zeppelin alone. Rigid airships are indeed possible. Well, it's essentially a rigid internal frame, obviously with an external covering for optimal aerodynamics, and inside there are multiple bags filled with buoyant lifting gas. And it's precisely rigid airships that we're aiming to move towards, starting by building soft ones like 2,000 cubic meters, 8,000 and so on as planned. Next, with a truly substantial 35,000 cubic meters of lifting gas, that's precisely the immense volume where you can actually construct a rigid airship, a truly impressive feat of engineering. Because you can't make a small one, the envelope itself weighs something, and a rigid envelope is heavy, so it simply won't fly, there won't be enough lift from the helium. But the surface area of the envelope grows significantly by the square, while the overall volume grows substantially by the cube. And since the volume increases cubically and quite rapidly, at a certain crucial point, the aerostatic lift becomes much, much greater than the total mass of that surface area, thereby making it entirely possible to successfully build rigid airships. The very first airship, which we've currently named Nova 2, is already steadily moving into the production stage. But if you've been closely following the project's development, you undoubtedly know that we're already actively flying a smaller yet significant prototype. We've officially called it Nova 01. It measures a substantial 130 cubic meters, making it a compact, agile airship. It is, in essence, a dynamic and precise replica of the Nova 2 airship. Allow me to proudly show them to you now. So the first one we have is a small airship with a volume of 130 cubic meters. We've named it Nova 01, and it's a dynamic replica of the Nova 2 airship. And here is the first serious airship in the lineup. It has a volume of 2,000 cubic meters. It's called Nova 2. We've already flown on the Nova 01. You saw our recent flights in Novinky. Thanks to that excellent airfield, and thanks to the very accommodating owner of the hangar for graciously taking us in. We flew there for a whole month, conducting extensive tests. What exactly were we testing there? It's not just a dynamic replica of this remarkable craft. A dynamic replica fundamentally means that the crucial ratios, for example, the significant ratio of aerodynamic drag to engine thrust and the overall area of the tail assembly, these essential ratios are meticulously preserved. However, these airships are meticulously scaled down to a smaller, more manageable size. This scaling is done in order to thoroughly understand the dynamic characteristics and aerodynamic behaviors of this particular airship. In addition, the fundamental design itself, the Nova 2, is specifically built according to a unique scheme where it possesses one main powerful engine and two distinct propellers which efficiently receive thrust directly from this central engine. All of this is mounted on a rotating transmission, that is, the propellers spin and redirect the thrust, so it can position the propellers to provide vertical thrust and ascend vertically, or turn the propellers to fly forward. The same exact design is implemented here. In other words, this is a complete replica of it. And there's a dedicated tail thruster for precise maneuvering at very low speeds. At speeds above roughly 40 kilometers per hour, the robust tail fins are actively engaged, and the airship's primary rudders come into effective play, providing essential directional control. With its rudders, the airship can effectively steer its course. All of this intricate detail is preserved in the small model, and within the airship, everything is precisely controlled by the sophisticated control system, which is essentially the computer. And the software itself, including the computer system, the flight controller, the specialized software specifically designed for the flight controller, and the essential dispatcher software, this is a completely separate and distinct program that robustly allows a remote pilot or a dedicated dispatcher to seamlessly connect to the airship. We meticulously created all of this, basically, well, just a mere month ago, so you can accurately count from August. And right now, we are actively testing this particular system on this very airship. In the various videos you have previously seen, we were mostly flying the airship using manual control methods. But the control system itself, or more precisely, the computer, the flight controller, and everything else, all of that is being developed specifically for this craft from the start. It's just that with this, we have the opportunity to test everything out. Right now, we have 3 control schemes implemented. The first is when there's an operator in the field with a remote control. It's just a regular one, like the kind commonly used for quadcopters, and for now it's more than sufficient. Within the clear line of sight range, we can control it quite easily. That's the first scheme. This is the safest method. In Novinky, we flew exclusively using this scheme, though we did try automation once. The second scheme is quite similar. The operator is still in control, but now they're located in a remote office in Moscow. For example, the operator can clearly see on the multiple monitors this advanced airship is fully equipped with not just one, but 2, 3, 4, and even 5 high-resolution, wide-angle video cameras which diligently transmit real-time video footage with minimal perceptible delay, thereby providing a comprehensive and expansive 360-degree panoramic view around the entire airship. And so this particular operator, while physically located in Moscow, possesses all the necessary control interfaces right here, can clearly see everything that is happening around the airship and can also effectively control it, essentially just like an operator working in the field, so to speak. This is the second control scheme. We haven't gotten to it just yet. It works, it's just that there are different situations and circumstances. For example, as you undoubtedly know, we just recently finished our flights in Novinky. We then had a significant month-long break and we subsequently went for further testing. Right now we're currently in Voskresensk. So there were some minor bugs in the code, which here in Voskresensk, when we successfully got it up into the air, we observed some truly beautiful footage. They're gracefully flying, and very soon there will be an impressive video from the quadcopter, which will be even more visually stunning and captivating. So, for example, there was a situation when the operator in the field would direct the airship up or down along its course, and the control surfaces would respond correctly, but the rotating beam with the main propellers, for some reason, started moving in the opposite direction. And since you're out in the field, you can see all of this right away. We landed it, and after 10 minutes of coding, we fixed it. It's just a bit more difficult and a bit riskier to do this while in the office. There are still a few minor rough edges. We're diligently polishing them out on the small prototype, but this system is already fully working. It's currently in the office, and soon we'll shoot a comprehensive video review of it. And here's the third and final system. This is when a person, the primary control system, can be located anywhere in the entire world. They simply need reliable internet access, and from a modern smartphone, a versatile tablet, or a powerful computer, they can easily connect, then open what I currently call our specialized dispatcher software, and subsequently see all the airships in real time. They select, well, for now we only have one. They select this particular airship and can either activate or deactivate its operational status, check all the essential systems, like the current battery charge, the internal pressure inside the gas and ballonette tanks, all the various temperatures, the readiness of all engines, and so on. So they can clearly see all the systems, and there are also several distinct modes available there. A mode is when, for example, on the map, they select Prepare for Flight, press the button, and the airship starts getting ready. Then they click on a point on the map, set the altitude, and, for example, specify the loitering radius. The airship takes off, flies to that point, and starts circling around it. You can set several points. At each point, basically, you tell the airship to fly there, make a few circles at a certain altitude and speed. All of these parameters can be set. At the second crucial point, you might indeed need to land, then stay at that specific spot for about a good half an hour, and then take off again, and so on. This particular software is also fully ready. We partially tested it in Novinky, but there we just set conditional vectors. That is, we disabled manual control from the remote. And while standing in the field with a tablet, we set the airship's altitude and vector. In other words, the commands are currently sent through a cloud server. Right now, the server is physically set up in our office location, so when we're out in the field, the internet and mobile connection send data to the server then processes everything, and then also via mobile networks sends it all to the airship. Inside, it has two distinct routers from two entirely different internet providers, and there is absolutely no perceptible delay whatsoever, just a mere few milliseconds. The airship receives the command and immediately starts flying precisely along the designated vector. This week, by the way, we are deploying the full and complete functionality of the software on our server. Starting next week, we will begin comprehensive testing, so please stay tuned. It is certainly going to be very interesting. So this dynamic model actually generated a lot of interesting responses from advertising companies. From those companies that genuinely need it as a robust and versatile platform for deploying their critical payloads, for example, for comprehensive environmental monitoring, efficient data relaying, and so on, the demand for such a sophisticated and reliable system is substantial and ever-growing. And in this significant regard, we are now at the crucial stage of creating not just a highly dynamic and intricate model of this advanced airship, but a truly full-fledged operational airship of the exact same impressive size, essentially a small, sophisticated, and fully functional unmanned aerial vehicle. We called it the AEROLET, also known as O1. It will look a bit different. It will have an interesting body, not a classic one. It will feature an unusual tail assembly. It will no longer have what you saw on this particular airship. The gondola itself simply replicates the precise geometric design of the gondolas on the Nova 2 airships. Not completely, without the fairing. That is just the essential chassis width and so on. By the way, one of its primary and most important functions is the precise feathering around the lower docking point, and now we are diligently starting to work on all of that with great care and attention. At the same time, the AEROLET is being produced, but it's not the O1 model, it's actually the ZO2. Here it is O1 because it measures 130 cubic meters. And here it's already up to 200, that's about 190 cubic meters. It's no longer a twin screw, it's a 4-screw. It has 2 additional screws. There's also a rather interesting bow thruster installed here. We sincerely hope to see this remarkable device in the vast sky by the very end of August. Our esteemed company is already diligently starting to send out comprehensive commercial offers for this innovative device to all genuinely interested parties. Indeed, they truly exist, and there are already 2 distinct types of commercial offers being meticulously prepared for the purpose of conducting important experiments. As a comprehensive service, we come, deploy not just one airship, but several are indeed needed, set them up with the customer's specific payload, conduct the experiment, and all associated services are fully paid. And based on the comprehensive results of the experiment, we will then move on to serial production, and commercial offers for the serial production of these specific types of devices have already been meticulously prepared and sent out as well. The initial experiments will definitely take place this year, and serial production will most likely begin early next year, possibly even at the very beginning of the year. The entire sophisticated control system, which was specifically developed for this particular device and thoroughly tested on it, will be entirely suitable for the entire comprehensive range of devices. We'll get to the entire and complete product line in just a moment. So this particular one is being developed much faster than anticipated. A lot of the details are already significantly clearer now. All right, let's move on, but that's not all we've achieved since the project started. I'll draw the line here. For now, let's move on to the Nova 2 airship. This is also a classic non-rigid airship, indeed a truly remarkable one, powered by a robust gasoline engine, specifically a powerful gasoline helicopter engine. These significantly smaller airships, on the other hand, are entirely electric. They operate efficiently on electric motors, which are reliably powered by conventional lithium-ion batteries. With this innovative airship, there was absolutely nothing that truly needed to be invented. Here, instead of a traditional battery, we're immediately installing advanced hydrogen fuel cells. So it will be much more expensive, well, relatively much more expensive in general, just more expensive, but its overall efficiency will be significantly higher. It will fly much farther, carry a greater amount of weight, and so on. The airship we currently have now runs on gasoline. It uses a powerful helicopter engine that is fully operational. This powerful engine not only turns the large propellers, it also efficiently powers the generators that charge the essential batteries, which in turn power the crucial tail thruster. Our tail thruster, as you can see, is entirely electric. Here, I've clearly drawn 2 distinct propellers. In fact, there will be a single, highly advanced rotor with a precise blade pitch control mechanism. I was about to say it's fully developed and completely finalized, but actually, it's not entirely finished yet. It is currently being developed in 2 distinct versions. The very first version of this system is completely unmanned. It possesses the remarkable capability to efficiently carry substantial loads, starting from a significant 500 kilograms and extending over impressive distances of at least 500 kilometers, operating autonomously, either with a remote pilot or even just a dispatcher overseeing its operations. And the second version is designed for passengers, comfortably accommodating a total of 6 individuals, specifically 1 pilot and 5 passengers, and it will be possible for it to fly for approximately 2 hours at a time. It could actually fly for a significantly longer period of time, but according to current aviation regulations, flights exceeding 2 hours are strictly not allowed if there are no proper restroom facilities on board, generally speaking. So our passenger version is now fully ready. Well, actually both versions are at precisely the same stage of readiness and development. It's just that one has progressed a little bit further in certain specific aspects and the other in different areas, but they are practically and functionally identical in their core design. But significantly different requirements apply to both unmanned and manned aircraft. And for example, you simply can't just take a manned aircraft, completely remove the cockpit, and then say it's now an unmanned vehicle. There are still quite unique requirements for unmanned vehicles, and similarly unique requirements for manned ones, so they do differ a bit. But overall, the fundamental concept remains essentially the same. There is already a significant and growing demand for these advanced vehicles in the market, and we are actively preparing comprehensive commercial offers and detailed proposals for them. We are collaborating with the very same established companies and organizations that are currently placing orders for our smaller, highly effective unmanned aerial vehicles from us. Because monitoring equipment, optical, radar, it all varies in terms of weight, range, clarity, and so on. And this particular airship, the Nova 2, operating in its unmanned mode, specifically as a dedicated monitoring airship, has consistently turned out to be in very high demand. There are many important things we need to carefully observe and continuously monitor, such as environmental conditions, active fires, vast ice flows, and as you know, other interesting and significant things, including large urban cities. Including what is currently being done and what will be done in the near future regarding this device. Let's start with the most important thing. Well, actually everything here is important, like the envelope. It seems big and significant. An airship without an envelope isn't an airship. We specifically ordered this particular envelope from a specialized Moscow-based company that expertly manufactures small tethered balloons, specifically ones that are even significantly smaller in overall volume than our Nova 01 ultimately turned out to be. They carefully crafted the envelope for us from the material they had on hand, which, while not absolutely perfect, is something for which we are truly and deeply grateful to them. Right now, no one in our entire country is truly capable of making a very large envelope like this indeed. Neither they nor the company from which we ordered this particular envelope. We ordered this one from another company that specializes in making various inflatable figures. We quickly realized that they possess truly good and advanced technology, highly skilled and creative designers, and consistently high-quality production capabilities. The only thing was that they really needed a bit of guidance on the specific details, help with choosing appropriate materials, and so on. We did a lot of extensive work on that, and now this envelope is currently in production, but again, they still aren't able to produce an envelope of 2,000 cubic meters or even larger sizes, and that's why we ourselves found the material, the fabric for this shell, a long time ago, and it's foreign made. Fortunately, we were indeed allowed to purchase it without encountering any significant obstacles, and they were quite happy that there was a clear demand for this valuable material. There are others involved in aeronautics as well, and this company is also in the aeronautics business, and they speak Chinese. We successfully purchased the necessary material, and they also greatly assisted us in carefully selecting the appropriate equipment on which these specialized casings can be efficiently produced. We have already made a significant advance payment for this crucial equipment, and now we are facing a truly major and important task ahead. Some of the equipment has already started to arrive, some is still on the way, and some hasn't even been shipped yet. The task is to set up envelope production. This is a comprehensive facility, and there are certain specific requirements that must be met. All right, there is only one particular path that we are diligently following. This is about setting up a truly rapid production process so that with absolutely minimal financial investment, minimal effort, and minimal time commitment, we can effectively pay for all of this extensive development and ultimately get the very first envelope for the Nova 2 airship. This path is already fully established for us. We have a clear understanding of what this facility is and where it is precisely located. When we move into that facility and commence the welding of the envelope, in the most optimistic scenario, we anticipate beginning operations in the early summer months. In a less optimistic one, we foresee starting at the very beginning of the autumn season. But that's actually good, having this large envelope ready by early autumn, because all the other systems are also currently in the production stage. And there is a second, equally important path, which is the comprehensive creation of a full-scale, robust serial production, a truly serious and significant one, where these specialized envelopes, both the current and future ones, will be efficiently mass-produced. This is a very large facility spanning thousands of square meters with a certain specified cleanliness class, impressively high ceilings and absolutely no columns. In other words, it is a truly single-span space. Ideally, the space should be about 60 by 30 meters, which is actually even more than 1,000 square meters. 1,000 is just the minimum. And of course, there should be some essential administrative offices and various support facilities and so on. For the present moment, we are actively addressing this particular issue through several distinct and comprehensive approaches. Of course, for an investment project, it would be absolutely ideal if this valuable asset were acquired and properly recorded on the company's official balance sheet, but for the time being, we simply cannot afford to do that. Moreover, within Moscow, the prices are absolutely enormous, and it's understandable that you might want to put that aside for now if you're looking farther away. There are technopolises, technoparks, and just regular rental spaces. Today, once again, we visited Moscow's technopolises and looked at some premises. It's quite possible we'll settle there, but for now, everyone is focused on the first option. A video with Sergei Semyonov will be released soon. It was recorded today. Take a look. He'll explain what this place is, where we're going, and where we're taking all the equipment. We'll be bringing it there. You'll like the news. The shell molds are ready, the shell structure is finished, the materials have been purchased, the equipment is on its way, and we've settled on a location. All that's left is the technical work and a bit of time. We're starting the production of the shell itself. By the way, this is one of the first major milestones of the project, which is that we've purchased specific equipment, metal cutting, portal milling machines. The metal cutting equipment includes an EDM machine, a 5-axis milling machine, and a 4-axis turning milling machine. And production is already well underway. Everything is meticulously set up, and we have a spacious facility that is more than adequately equipped. Right now, we are actively manufacturing the crucial tail assembly for the advanced Nova 2 airship, as well as the intricate swivel transmission. It's been fully and comprehensively designed. The robust engine frames as well. By the way, the powerful engine for the Nova 2. Many people are already aware of this, but for those who haven't heard the news or perhaps missed it, the engines have already been fully paid for and are also currently on their way to our country. We specifically ordered 2 of them. They are of Belgian origin. So in general, production is starting to come back to life. It's starting to operate. The engineers, while working on the design of the gondola, are already producing drawings for the gondola itself. So far, we've made a bit more progress on the passenger version because it was a bit more complicated and we started a little earlier. So this summer, in August, we'll be watching in our video reviews how these large structural parts are being made. I'll be explaining the advanced technology we're currently using to manufacture all of this, precisely why we're doing it this way and so on. In short, it will be quite interesting. The control system is now ready. So that's the current stage of the Nova 2 project. Everyone has certainly heard the recent news about the shell production. However, things are proving to be a bit more interesting when it comes to the drone itself. It's quite likely, at least I feel pretty certain about it, that this is exactly what will happen. It will take off much faster, of course, than the standard passenger version. This accelerated departure is a key characteristic of its design. The engines there are a bit different. For the passenger version, the engines have to be aviation grade, certified, and therefore expensive. For drones, there are loopholes. In general, you can use different engines, and many people in aviation, especially in light aviation, take advantage of this. This is called auto-conversion. These auto-converted engines have already been selected, and they will actually be more powerful than the aviation certified ones. And the airship will fly in a slightly more interesting way. The control system is the same, the swiveling transmission is the same, and the fuel system is the same. Overall, everything else is pretty much exactly the same. Well, the gondola has been slightly modified. We will do a comprehensive review comparing the two distinct airships once we have successfully built them. So this is the stage it's currently at in the design process, by the way. Here are the ducted fan engines, the propellers themselves, the bevel gearboxes, and the swiveling transmission. In short, this entire propeller motor assembly has been completely designed by our team, just like the entire control system was fully designed by us, and all the software was written by us as well. We were planning, as they say, to work in broad cooperation, but in the end, if you want something done right, you have to do it yourself, as it turned out. And soon we'll also be seeing the ducted fan engines. Their production has already started, materials are being procured, parts are being manufactured, and so on. These are very critical and important components, both overall and for the country. Honestly, we'll be able to feel truly proud when all of this is being thoroughly tested, even on a ground stand. I sincerely hope that this entire process will start very soon. In fact, it will begin once the engines finally arrive. The engine is on its way. Let me digress a bit. Anyone keeping an eye on the weather around the planet knows that there are currently some minor anomalies happening in Europe. Because of the heat, their work weeks have been shortened, and so on. The engine was supposed to arrive this month, and at the beginning of August, we were supposed to assemble everything and start testing. If it arrives in August, then it will be at the end of the month. The weather, as you can see, things are unusual in Moscow as well, and I'm sure in your cities too. There's probably widespread minor bad weather. Got a bit distracted there. This is the current stage of the Nova 2 airship. The next airship in this series, well, I won't reveal it just yet, is the Nova 8. But just know that aerolets are classic airships, and these ones we've called aerolets. They're hybrids. They differ from classic airships in that classic ones mainly rely on their aerostatic lift to carry the entire load. Of course, they also use engines and aerodynamics, but those only account for a certain percentage. This hybrid can carry much more. That is, with the same comparable volume of helium filled into it, it can carry more cargo because its aerodynamics are better. Well, let's say they're better. Although aerodynamic principles are present here, they are present everywhere, but its power-to-weight ratio is much more significant. In reality, most likely, we'll ultimately end up somewhere around this particular point here with the classic ones, primarily because a very recent study, which was also meticulously conducted by our esteemed company and expertly led by Vadim Zubkevich, clearly showed this. This study clearly showed that hybrid properties, specifically hybrid ones, make a significant difference. For example, in the classic case, a dirigible can carry, say, 500 kilos relative to its volume and weight. But if we make it truly hybrid, it can carry a full ton or even 1.5 tons. And so, using complex formulas, the fundamental laws of physics and mathematics, as well as the principles of aerodynamics and other crucial factors, we proved that by equipping the classic shape with more power and making some precise adjustments to the tail assembly, it also successfully generates lift. It is possible to increase the degree of hybridity of the classic dirigible shape, meaning you don't necessarily have to radically change its form. It can remain classic. And we will certainly apply this innovative approach in future airships, because the significantly increased degree of hybrid lift in this particular craft allows us to effectively avoid one of the main drawbacks that has become historically associated with all traditional dirigibles, namely having to constantly carry cumbersome ballast. Basically, when you ascend in a classic type dirigible and then proceed to unload the cargo, if it happens to be a cargo or transport airship, this monitoring airship, everything is perfectly fine here. It's not planning to unload anything at all, but if it suddenly wants to unload a significant amount of cargo, for example, weighing approximately 500 kilograms, it will instantly become much lighter than air and consequently try to ascend rapidly. To prevent this particular issue, ballast equal to the precise weight of the unloaded cargo is carefully added to it. If the airship is a hybrid, let's say, it can effectively carry a significant ton using its aerodynamic lift capabilities. Then after the unloading process, it seamlessly transitions into a perfectly balanced state. It becomes something like a classic traditional airship and can calmly and effortlessly return without needing to load additional ballast, or it can continue its planned route and so on with ease. We will be using this system on large airships, and most likely we'll start with the Nova 8 airship, although it's not necessarily limited to that one. Let me just sketch something else here as a brief and intriguing teaser. The Nova 8 is specifically planned to be a classic-shaped airship, designed with a timeless and traditional aerodynamic form, and it is projected to possess a substantial internal volume of precisely 8,000 cubic meters. In its classic configuration, it can carry up to 3 tons. In the hybrid version, even more. Here, everything is pretty much the same as with the Nova 2. You can make unmanned cargo versions, or you can make passenger ones. I also wanted to touch a bit on the important topic of certification. As it turns out, the current situation with aviation certification in our country is quite interesting and presents some unique challenges and opportunities. It's a very long, incredibly expensive, and exceptionally complicated process, but all of that absolutely applies to type certification. Type certification is when you officially take people on board, diligently collect money from them, and then safely fly over densely populated areas. It is quite likely that airships of this considerable size will be able to operate reliably on regularly scheduled routes, in other words, in virtually all weather conditions, including challenging ones. There are certain interregional flights, and therefore, most likely, starting with this innovative airship, we will definitely need comprehensive certification. There will be a specific, carefully determined number of passengers, and it will cover certain significant distances. Let's say, for example, I'll write here a payload capacity of 3 to 4 tons, covering a range of about 2,000–3,000 kilometers. Here, for now, I'll just write that it will accommodate approximately 19 people, traveling about 1,000 kilometers, which is a substantial initial operational range. That's precisely how the situation stands, and this particular version will absolutely require official certification. In this specific area, over this extended period of time, we've diligently worked through a multitude of different options, various companies, and numerous specialized experts. We also extensively consulted with Rosaviația, and those detailed conversations were quite entertaining and insightful as well. They said, guys, your chosen path will indeed be thorny, but it will also be truly heroic. Overall, everything is absolutely possible. And now a dedicated working group has already been officially formed, and the entire comprehensive algorithm for all further actions is completely and utterly clear. And now, well, it's built, it's flying, and another one is currently under construction. Soon it will also fly, and then it will go into production. It's being built, and I hope we'll get it in the air by the end of the year, perhaps even a bit earlier. It's being designed. At the design stage, well, let's say if there is an external client, the company receives the technical specifications, and as soon as the technical specifications are received, the certification procedure can begin. In our case, since we ourselves are the internal client, we initiate R&D, and when starting R&D, that's when the procedure itself needs to be launched. We initiated the procedure to launch this process. In short, this is still a non-rigid airship, but now with a slight degree of hybridity. If there were a gasoline engine here, in these different versions, there would actually be 3 possible scenarios. Let's start with this. In this particular version, the impressive airship is equipped with 2 powerful generating units on board. These units efficiently burn fuel and subsequently generate electricity for all onboard systems. The electricity is then efficiently distributed, and powerful electric motors turn the propellers. The generators are strategically located somewhere on the underside of the structure. This scheme will be applicable to such a device. It will be applicable to this drone, so to speak. These power units are being developed by our company. I have hinted at them many times, perhaps even revealed a little bit. In actual reality, these are quite serious units. I can now definitively say that they are indeed microturbines with integrated heat exchangers. We're actively building a truly huge and dedicated team here. We've already successfully set up advanced computing centers within the office premises. All the intricate gas dynamics, the significant thermal expansion, and countless critical frequencies and rotations, it's all meticulously analyzed and managed right here. Everything about this experience is incredibly fascinating. The entire team is as professional as it gets. It's truly like we've won the lottery. And now, these units are specifically designed and engineered to handle a substantial 300 kilowatts of installed power, which is dedicated for the primary purpose of generating electricity and providing a reliable energy supply. Here, 2 powerful units of 300 kilowatt each are enough to make this machine truly fly. They are incredibly eco-friendly, remarkably durable, do not vibrate at all, make absolutely no noise, and offer a great deal of truly interesting and significant perks for the field of aeronautics. I will talk about them a little bit later on, as well as about these particular systems. We have already started producing them in hardware now, so in the near future we will see what they look like and what they are. I hope it works out, and then, in this type of device, these installations together, in general, this concept will be implemented. The shell production facility that's currently being meticulously set up for the Nova 2 is indeed temporary, but it's quite likely that it will also be fully capable of producing the essential shell for the airship, and that won't take a significant amount of time at all. Literally, right after we finish building the airship with a volume of 2,000 cubic meters. We'll test it, carry out factory inspections, check the shell, and so on. We'll assess the readiness of the production. It's quite possible that even this year we'll be able to start welding this shell. Ideally, of course, we would start right away at the large-scale facility so we can move on to serial production. Because for this particular type of craft, these specific ones, we have a very specific demand, a dedicated customer with a concrete and detailed assignment. There are also several other configurations available here. It's also entirely possible to effectively utilize auto-conversion in order to create sophisticated distributed engines that are capable of directly rotating the propellers without the need for any external electricity. You could use slightly different generators, though you would lose a bit in terms of weight, because these ones are much lighter than the current ones available on the market that you can get and use. In this particular geographical area. In fact, I want to say that we've made significant progress, and I say this because we have a very specific technical assignment from the client detailing exactly what the craft should be like, what its power-to-weight ratio should be, what ranges it should cover, under which weather conditions, specific types of cargo, types of mounts, and so on. And having a truly high-quality technical assignment is already half the work done. Usually what happens is the client comes in and starts developing the technical assignment together with the contractor. But when a truly qualified client comes in, it's a real pleasure. That's why I believe the depth of development for this particular craft is quite high. Here, we're still lagging behind for now, unfortunately, but everyone is currently focused intently on the Nova 2, on this passenger version. We're keeping quite quiet about the aerolets for the time being. Starting from this volume, it's clear that the first one currently being developed is the Nova 2, designed for a nominal 500 kilograms. Why do I say nominal? Because, for example, having such a powerful and efficient power unit, we can effectively use it on this particular craft. In that specific case, its overall power-to-weight ratio significantly increases, and according to Zubkevich's precise calculations, we can confidently double all these impressive figures here. We will certainly give it a try and observe the outcome. However, it is highly probable that the results will unfold in a manner quite similar to what we experienced with the Nova 01 project, which had its own set of unique challenges and eventual resolutions. We simply demonstrated the initial possibility of creating a craft of this particular class, and then customers came with specific requests, so we are just releasing a significant modification. It's certainly different, but still within the same general size category with very similar systems. And the very same thing will certainly happen with this particular airship. Most likely it will gradually become a bit larger. Here, We deliberately limited ourselves by the precise height of standard gates so that we absolutely wouldn't have to construct any non-standard structures or even utilize aviation hangars, which are typically used for very large airplanes, in order to completely avoid building anything at all. But surely there will be even further significant modifications for customers in the foreseeable future. It is already a remarkable product in itself, because here are the precise specifications: 500 kilograms and 500 kilometers. Well, 500 kilometers if we go full power and fly from point A to point B, but that's not necessary. Most likely they will be used for monitoring. There is probably demand for monitoring applications. In that case, it is not necessary to run the engine at full power. It is sufficient enough to cruise at 30% power for an extended period of loitering, which significantly increases the loitering time, and so on and so forth. Plus, since we don't actually have to utilize those 500 kilometers, which were originally calculated for an aviation engine in the passenger version, this provides a notable advantage. And since ours is unmanned, not for passengers, we can use auto-conversion, which means we can use not gasoline, but for example, even gas. There are also many other different tricks, and we can keep increasing and increasing its range and so on. These are all further modifications that are already being worked out and planned. So, what's my point? My point is that this type of airship will also exist. The Nova 2 that we're making is a demonstrator. Of course, if there is indeed demand for the demonstrator as it currently is, and we genuinely don't need to change anything at all, we can certainly proceed to produce it. And with the production capacity that we will gradually acquire over the course of this year, the initial year of the project, we will be able to meet this demand with small individual single units, so to speak. To move to full-scale serial production, whether it is small-scale or large-scale, we will certainly need to significantly expand further. This means that we will also have to expand our crucial envelope manufacturing capabilities. But again, most likely through renting, because purchasing a property doesn't seem financially feasible at this particular point in time. And we'll also need to significantly expand our current mechanical production capabilities. Right now, we're cramped into 300 square meters. We can easily assemble the gondola, the slewing transmission, everything will be done there. It's really not a problem, and it's possible to repeat the same process for both this one and that one there. But if it's a series, it's better to reorganize it a bit for production efficiency, like splitting up functions and adding more people. And in general, mass production requires a completely different approach. Right now, we're at the prototype stage, but mass production has entirely different requirements. Moreover, to implement these machines, a rather large staff is indeed needed, according to all the established norms and regulations. And that's all entirely correct. And consequently, the internal factory oversight bodies become very serious and deeply involved. For example, incoming quality control is done by the specialist who will later work with that material, but in mass production, that's impossible. Quality control is a completely separate and distinct branch reporting directly to different deputy directors and other relevant personnel and so on. So, in general, production is possible. That was about the modifications. Basically, it's soft, 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 and the next one will be a rigid device. For now, we are currently aiming for a substantial 35,000 cubic meters of volume. Let it be a truly rigid one. Most likely, the comprehensive scheme that will be meticulously worked out on the Nova 8 will undoubtedly be repeated here, precisely because, as I previously stated, it is a proven and effective approach. We're moving from small airships to larger ones, carefully creating these systems, thoroughly testing their reliability and quality, making necessary modifications, and storing all the best solutions in the subsequent larger vehicles. For this particular craft, starting from an impressive 35,000 cubic meters, it makes perfect mathematical and sound economic sense to have a robust and rigid hull, and it consistently proves itself to be truly worthwhile. This design choice is indeed optimal, but due to the inherent fact that the hull possesses significant weight, with the classic, not the kind of hybrid design we are now progressively moving towards, its potential payload capacity would realistically be around 10 metric tons. It would be able to fly, well, roughly 5,000 to 6,000 kilometers. I always tend to get somewhat mixed up with these specific thousands, primarily because it's actually a very substantial distance, and for now there probably won't be a practical need to fly quite that far. So 10 tons. And it would seem, right, here you have 35,000 cubic meters, here 8, well here almost 4, and here 10, because of the rigid hull, but it's still economically viable, it's efficient. And this represents the smallest rigid airship currently feasible within the rigid series. However, looking ahead, it is clear that we will need to progressively scale up to much larger capacities, specifically reaching 30 tons, then 60 tons, 100 tons, 200 tons, and even 300 tons. It is also abundantly clear where these larger airships will be utilized, precisely who will benefit from their capabilities and the specific needs they will address. But for now, I think 10, 30, and 60 will also be good benchmarks. The 10-ton model will most likely become truly mass market, the 30 and 60-ton models as well. But those vehicles with a significantly higher payload capacity, well, at first, while the global economy, political landscapes, and business sectors are gradually getting accustomed to this entirely new type of specialized vehicle, it's quite likely they'll be unique, one-off, bespoke models, but they will certainly exist and play a crucial role, because it's clear where they can be used and where there is demand for them. With the Nova 35, we've reached the point, well, obviously, all of this is already accumulating in this piggy bank, but here we need to focus on developing a rigid hull because everything else just fits into it. We started working on the rigid hull. Of course, there were a lot of developments, various ideas and so on. But when it comes to practical actions and their actual implementation in our country and really in all countries across the globe, with the notable exception of the United States, where Sergey Brin personally took on the monumental task of meticulously building a rigid hull, no one else has truly accomplished this for a very, very long period of time. So of course, theoretical considerations and detailed calculations are all exceptionally well and good. Now we've successfully moved on to more comprehensive and detailed modeling. Obviously, most of this takes place on computers. There are several proposed designs, about 5 in total. The designs differ drastically, ranging from space frame structures made of carbon tubes to something I won't disclose yet, because for now it remains a trade secret for the entire world. Brin built his magnificent airship using advanced carbon tubes. Sergey Brin, the brilliant co-founder of Google, he meticulously planned it, and he personally constructed the very first truly huge, rigid airship, yes indeed in the 1st century. But again, he started right away with a considerably large airship demonstrating his ambitious vision. They spent many years working on it, and a lot of the mistakes that were made at the very beginning prevent this airship from being as efficient as it could have been. Basically, it has a huge volume, but it carries less than this one. Never mind that, it is important to note that there are certain innovative designs meticulously crafted from advanced carbon tubes and intricate spatial structures that will specifically allow this remarkable craft to efficiently lift a substantial payload of approximately 10 tons when operating in a sophisticated hybrid configuration, and it could potentially be even more in the future. Some parts we even model at full scale, though there is still some degree of scaling involved. Just like we meticulously did with the Nova 2 airship, we carefully made a small dynamic copy of it. We also precisely recalculated these large spatial trusses to a more suitable scale for working comfortably in an office environment. We have since acquired high-quality carbon tubes, are currently building certain critical structures, and will be thoroughly testing them very soon. There are still a number of other schemes. For the rest, computer modeling is currently underway for the most part, as well as scientific research, I would call it that, because there's a lot of interesting work to be done there. With this payload capacity, this version, if converted into a passenger model and seating people as in an airplane, could carry about 120 people and might be able to travel long distances, covering significant ground and extended ranges. It's unlikely that this is necessary, considering that airplanes already exist. They fly much faster, there are many of them, everything is well established, and it's not worth getting into that area. But when it comes to creating drones, they are needed. They can fly farther than helicopters and can also land. This is the most practical machine. Everything is clear here. But there are cargo aircraft and they don't necessarily have to be unmanned. For certain cargo, a pilot will still be required. They will also be optionally piloted. Special purpose vehicles, particularly when people who are professionally compensated for this work are on board rather than simply passengers who pay for the ride, will also be effectively used for transportation purposes. Just packing 120 people in there and sending it somewhere as a flight, I don't know, maybe someone, not necessarily in our country, would genuinely want something like that, but it's quite unlikely. It would be far more interesting to turn it into something like an expedition airship for travel purposes. Seeing the world from an airship feels completely different. It's neither like being on the ground nor on a plane. When you fly, you can't really make anything out. The clouds are way up high. Here, you're flying at the most luxurious altitude where you can see everything, understand everything, and calmly stroll along the open decks. Now, there is demand for this kind of craft. And then, as you can clearly observe, it meticulously continues according to the precise dimensions. And at this specific point, we will carefully draw the definitive line. This is precisely what we formally declared for airships over the course of the next 5 years, outlining our strategic vision. And right now, we find ourselves at this current juncture, with not even a full year having elapsed since we initially started this significant endeavor. This impressive airship, as I mentioned to you, we will be fully able to build using the facilities that we will have fully set up over the course of this year, specifically to meticulously manufacture its various components and so on. For example, to carefully fill it, thoroughly test it, and then securely store it somewhere, or to diligently repair it, regularly service it, or precisely modify it. It's not strictly necessary to repair it, although that will definitely be required as well. We practically don't have such extensive facilities in our entire country. And most likely, starting from this considerable size, it is indeed time to begin the crucial process of building substantial hangars. It's quite possible indeed. Various concepts are currently being meticulously worked out, and everything is being carefully calculated, economically, of course, with great precision. You need to build for this situation, but it's too big. Though not bigger than for this scenario, if there are 2 of them, if there are more with these items. In general, right now work is underway with several, well, so-called design companies. We're currently gathering all the necessary construction proposals and meticulously evaluating them because it's now the opportune time to commence, since we already have the foundational shell production and the mechanical part completed. Literally next year we'll be entering the active phase of manufacturing this sophisticated device. There is absolutely no time for construction. There are temporary solutions, but our economic department is questioning them. I've already talked about this, but for those who haven't heard, I'll repeat it. There's a technology for pneumatic frame hangars, and it fits perfectly. The Nova 2, these are practically standard sizes for such hangars since they're also made for airplanes. Here we were actually quite significantly limited by the truly enormous airplane-sized hangars, but over here it's incredibly easy to manage and operate. The same pneumatic frame hangars can be made for this particular craft as well, but they will actually be more expensive because they're not standard. They'll be larger. And again, this isn't permanent construction, it's not an investment in a fixed asset. Although this pneumatic frame hanger can later be happily and efficiently sent to the very customer who genuinely needs these crafts, simply so they can store and service them there from time to time, ensuring their continued operational readiness. So that's one possible solution. Obviously, everything is currently leaning very strongly towards construction, indicating a significant focus on building new facilities. Right now, various different types of hangars are being carefully considered and evaluated. For example, for the serial production of these specialized crafts, you can construct a facility of clear and precise dimensions with well-defined interior spaces, specific functions, and so on. We've meticulously developed the comprehensive technical specifications for a dedicated hangar, specifically designed for the serial production of these crafts. These are already large, permanent, and substantial buildings. there are 2 of these, 2 of those, and 1 of this. In general, there are different combinations. 1 of this, 2 of those, or even the next one, where there are 2 of these per month. Right now, we are actively collecting all the commercial proposals. We are basically evaluating everything thoroughly, and they are already coming in. It's about time. Well, I truly believe that by the very end of this current year, we absolutely need to make a definitive decision in this particular direction. Yes, the significant news that Simayanov will officially announce in the upcoming video is directly connected to the crucial decision that will be more than enough for us. Just one more important thing. It's permanent, first of all, and it is extremely useful. But for these particular types of devices, unfortunately, even these devices will last for many decades of work. We are in negotiations about where a large boathouse will be built for assembling and testing this device, or even this one. OKIT, Special Economic Zone, Aerospace Cluster. We mentioned at the conference in the fall that we are joining them, and we are actively working with them on projects in this direction. There are many different situations, pitfalls, and so on. This site is being considered as the most promising one, where it is quite likely that major construction will take place. But there are also other viable options available in Kazan. For example, there was a proposal, because they also genuinely need such facilities. And there's another one for this, which isn't currently here. They need airships as a customer, and in Yakutia as well as a customer. Maybe everything will happen there. In general, all of this is currently being analyzed and worked through very closely as well. But for now, we're all focused on the here and now, though we're also moving forward with long-term plans. We're pushing ahead, and fortunately, everything is moving as it should. Well, in short, that's probably the current and present state of the project and exactly where we are right now. The company currently has about 65 dedicated employees, and among them, the engineering and technical staff, basically the managers, make up a very small percentage, which is embarrassingly low, actually. Most of the team are designers, executors, technologists, engineers, and machinists. So we're actually still short on engineering and technical staff, I'd even say. The managers have to juggle a lot as a result. We're still based in our office in Moscow, on Bolshaya Akademikskaya, with 1,000 square meters. Well, it's just over 750 here. We've also rented 2 more offices. There's 300 square meters of production space in Lyabertsy. And soon there'll be a new facility, which Simayanov will talk about. That's pretty much it overall. Sorry, I can't see your comments or anything else. We don't have a screen here, and I haven't taken out my phone yet. About to buy, by the way, we're going to the upcoming exhibition, and everything worked out perfectly in the end. There's going to be a truly major international aviation exhibition held in Dubai, featuring literally all the top and most prominent companies in the world connected to both aviation and space industries. It's going to be a huge exhibition, and it'll take place in November. So, AERONOVA will already be there, and that's official. I'll ask now to have the link sent to the group chat. Go check out the exhibition plan. Look for the AERONOVA booth. That's some good news. We've started getting ready for the exhibition very actively. This is also one of those big,
I'd even say fundamental milestones. And it's really just around the corner. Summer will end, early autumn comes, and bam, we're already at the exhibition. And the whole world will find out about us. Major players and big investors will hear about us. And we have something to show. By that time, we'll have a lot more to show and talk about, and we'll be able to announce our plans there. So we're taking this very seriously right now. If you're in Dubai, visit. If you weren't planned to, make plans. Dubai is close. It's not a long flight, though I'm from Moscow's perspective. You might be coming from elsewhere. I think we can be proud that just a little over a year after starting this project from scratch, we'll be standing there. You'll see for yourselves who will be there with us. We really do have something quite significant to show you, and a truly very cool and exciting event awaits us all. I remembered the exhibition. By the way, our website has launched for AERONOVA. If you haven't seen it, it's still under development, and we'll keep adding to it. But not the project's website, the website for the manufacturing company. I call it a manufacturing company or design bureau. Anyway, the website for AERONOVA is up, and they'll send a link to the chat right now. Go ahead, check it out. Leave your comments, suggestions, and ideas about what you'd like to see there. Obviously, the website is being developed to shape the company's image in the market. Right now, we're working with serious organizations and departments, so the website needs to reflect that. Plus, it also needs to appeal to potential clients. It's clear who the clients are for this type of equipment. So go ahead, take a look, get interested, enjoy it. All of this is being done so that this machine can get up and running. I mean the business. All right, now let me check the questions. Write in the comments if you liked my lecture about the current state of affairs. I'll read your questions now. Hello? Should we expect the first manned airship flight in 2026? Yes, of course. You should doubt we were actually expecting it this year. And if the stars align, maybe even in 2025. The airship is 35,000 cubic meters. That's like the Hindenburg, which could carry 90 people including the crew. But this one can take around 20. Earnings from stratospheric probes have taken a back seat. Yes and no. The clients who come for monitoring purposes are also interested in stratospheric platforms. Because of our highly successful launch into the Earth's stratosphere, which almost made a complete round-the-world trip, demonstrating its impressive reach, major and influential players decided to actively get involved in this significant area. And based on Boumanka, a major scientific project has now been developed to modernize and significantly improve these stratospheric platforms. We have successfully reached a comprehensive agreement with Boumanka that this important activity will, of course, be carried out jointly and collaboratively. Honestly, we can't keep up, I admit. The process of covering this has been poorly organized. Launches into the stratosphere are happening, and they're happening quite often. There was one last week, there will be another next week, but all of them are scientific and technical in nature. Of course, it would be great to watch the progress, But all this progress is focused on the fact that by the end of the summer there will be several targeted launches, both on behalf of the company AERONOVA and independently by Bomenka itself. We will be launching various payloads with the primary aim of thoroughly demonstrating this crucial experiment for its eventual and successful commercial continuation. With Bomenka, we realize this is uncharted territory, and developing the commercial direction is more challenging than scientific and technical progress. And to put it briefly, we threw all our efforts into finding a client. No one is limiting anyone. If you bring in one client, that's great. If you bring in another, that's awesome too. In general, we will also be demonstrating the stratospheric system in Dubai on the international stage. I think there will be strong interest, given our current experience. The most important thing is the state of the team and our readiness to implement projects. So, the stratosphere is not standing still. How many Nova 01 units have been ordered already? Well, I can't say. It's a trade secret. The lecture was great. Have you discussed suspension systems for the cabin? I can't understand the question. Should the cabin be suspended, or are you talking about suspension attached to the cabin? Well, naturally, everything gets discussed. When the project was starting, taking shape, that was more than 4 years ago, maybe even longer. But back when it was starting, yes, all sorts of ideas come to mind. Like, oh, we could do it this way, or that way. There are so many possibilities. And then, after working for even less than a year, you end up having so many different discussions during the work process. Those fantasies that used to seem like brilliant ideas fly by now, like another solution. It's better to toss them out. How many Nova 01 units will it take to pay off Nova 2? Well, it depends on what margin you sell Nova 01 at. Because there can be different schemes, and they're already different. In some cases, AERONOVA might be selling Nova 01 directly to the end customer. In other cases, AERONOVA will sell Nova 01 to the main company, which will then install a range of equipment, and only after that will Nova be sold to the final client. The margin is one thing here, another there, and yet another elsewhere. Nova 01 wasn't created to cover the costs of developing Nova 2, but if you do the math. About. Actually, I won't say, otherwise people will start asking about prices and so on. So let's just say we've switched to commercial secrecy mode. They're not meant to pay off Nova 2, but if you count the units, it's possible. And even Nova 2 isn't meant to pay off Nova 8. The margin grows along with the device. Roughly speaking, Nova 01 or Aerolet 02. For example, there's a market, and in that market, there is equipment capable of performing a certain function, say, lifting 50 kilograms into the air and transporting it over a certain distance, or staying airborne for a specific amount of time. This kind of equipment already exists, for instance, with small airships. Even with these helicopters, for example, they exist, like the Mi-8, and this equipment has a price. Obviously, if your product has the same functions and the same quality, you can't set your price 2 or 3 times higher than theirs. Well, if you actually deliver the device itself in the end. But if you have some additional features or some features are better, like its quality or specifications, Then you can reasonably increase its price by a predictable amount. And with small devices, everything is clear. There are quadcopters. You can just Google them. Well, roughly speaking, let me put it this way. Say it can carry 50 kilograms for 200 kilometers, or it can keep 50 kilograms airborne at an altitude of 1 kilometer for about 6 hours, just as an example. It's easier not to Google it, to ask DeepSeek or another neural network. Personally, I like DeepSeek. It will immediately pull up options from the internet, so you'll be able to see the market. So, roughly speaking, by considering various options, including those from the internet, we now realize this little airship has unique properties. And we can sell it for much more than what's available on the market. But the goal isn't to cover the costs of subsequent processes. Everything will become self-sustaining and profitable, just not instantly. Not in the sense that we sell one and immediately recoup our costs. That will happen here. It's quite likely that with serial production, we'll actually recoup everything right here. Here too, the profit margin is huge. This is an extremely unique device. There's profit here. The cabin tilt is adjusted for compensation, and so on. If it's some kind of highly sensitive cargo, for example, obviously a special suspension system is developed for stabilization. But inside the cabin, automation will control the airship. Just like on Hindenburg, they sat calmly, drank beverages, drinks stood on tables and nothing happened, and that was 100 years ago. Now we'll fly more stably. We've discussed wilder ideas, suggestions that the cabin could float inside the airship. It doesn't have to stay in one place. We could rotate the hull and take off vertically like candle. On August 23rd to 24th, there will be ballooning festival in St. Petersburg. 30 hot air balloons in the sky, 12 million spectators. Aliana, do you hear me? On August 23rd to 24th, there will be a ballooning festival in St. Petersburg. Should we take part with our crafts? Thank you. And what are the approximate sizes of all of them? I didn't want to write down the sizes. 17 meters long, 19 meters long, 44 meters long, about 75 meters long. Everything is still up in the air here because the design keeps changing a bit. I won't even bother writing it down. That's how much it's all still up in the air. Wow, that's both scary and fascinating. Thank you. Thank you. Judging by the project timeline, AERONOVA is building the site right away for the Nova 35. I can't disagree, but we need to significantly increase funding. We don't even have the ability to save up because generators are being purchased here, high frequency, high-speed motors are being bought, materials are being acquired. Everything is going like this. There's enough money, but not to save, and here we'll have to save up. Will AERONOVA be providing services using the Nova 01? Yes, it will. Most likely, this one will be providing more traditional types of services. It's quite possible that, with a bit of modification, it will as well. Will the production airships be made from domestically produced film? That's a good question. We have several enterprises that, in theory, are capable of producing domestic film. but all of them truly require significant investment in their production processes. And it's quite possible that our innovative project will indeed motivate them to invest more substantially in modernizing their very own factories. It's not much, actually, and there's nothing overly complicated about it at all. And yes, then they will certainly be able to produce material of the precise quality we genuinely need. Right now, we are already able to provide a specific technical specification, almost the entire composition of this material, what the base is, what fillers, what films, all the requirements for these materials. Of course, when you localize everything together, where they are developed and produced. As people like to say these days, we're building technological sovereignty and also hoping that it will be economically justified and reasonable. That's the other side of the coin. When you launch fabric production lines, they absolutely need to run, and keep on running. The fabrics probably need to be produced by the kilometer every day so that, with a classic approach, these machines paid for themselves within a reasonable time frame, and so on, and so forth. But if, overall, the enterprise is profitable and there isn't a super commercial goal to recoup everything immediately, then it's quite possible that we can figure out some economic feasibility together. So, those are all the questions that have been sent to me for now. What are you going to do about the gas permeability of the envelopes? How long will the craft stay in the air? Actually, even the current envelope on this airship has shown me, at least, that there are absolutely no problems with gas permeability and no issues with helium contamination. All of that is, I don't know. I can draw an analogy. As a mechanical engineering technologist by education, we had courses like special precision machinery and so on and so forth. And when you really dive deep into a particular subject, you realize, well, you start to encounter certain difficulties, barriers, and so on. When you don't know about them, you just go ahead and do it, and most likely everything is a bit simpler. Obviously, the same kind of professional bias has probably developed among international airship specialists as well. Everyone just keeps getting hung up on these little details. In reality, against the bigger picture, you can't even see those details. But as always, that's just how it turned out. For some unknown reason, people love to discuss all sorts of nuances and mistakes instead of focusing on usefulness and benefits. And this social habit has led to questions about what to do with gas permeability. Even though, with this device, we clearly understood that everything is fine with it. With these fabrics, it will be even more fine for sure. Gas permeability is fine. Helium gets dirty, contaminated. Partial pressure. Here you have a portion of one type of molecule. They're a portion of another, and they want to get inside, and they do get in. No problem. That's what helium purification systems are for. It will take a long time to get contaminated, but then it will be cleaned quickly and keep going. No problems there. By the way, there's a whole big area at work here. I've only scratched the surface. Even for helium purification systems, active development is ongoing. Development is underway, but the Germans already have it. It's expensive, and so on. We have the expertise to create the same thing. We really don't see any problems with this at all. We're also creating a mobile version right away, which will be on board, relatively compact, processing small amounts at a time, but it will compensate for contamination up to certain volumes. And we're developing a ground station, which can quickly handle situations. Anything can happen, like a leak, so you need to quickly repurify and reload. we're working on that system too. Well, obviously, when we say we're developing, it can mean just thinking about it, coming up with a concept. But in reality, things have already moved much further along. Of course, the helium purification system itself is made up of several components. We're making most of this system ourselves. There are special cartridges involved, but there's really no point in manufacturing those ourselves. It's like trying to start making microchips from scratch these days. Why bother? The cartridges are available. They've been selected. All the equipment has been chosen. The vacuum technology has been picked out. We've already moved in that direction. Now, if we're talking about the scientific and technical side of things, research, what we call in the lab, we'd need at least 2 more webinars to cover all that. I hope we'll soon start getting some really interesting content from there. It's already fascinating as it is. It's just that the filming process is still being organized. Is it possible that a major investor from the UAE might join the project? We're hoping for that. I hope so, and I think you do. We'll be bringing the investor on board as a client for specific devices, taking orders. Just like it typically happens here in this country, the client provides the designated site. We then proceed to construct a spacious hangar for them on that very site, and subsequently assemble the airship there. What kind of significant interest is there in AERONOVA from other countries around the world? At the very beginning of the project, back in the early fall, we did a quick and comprehensive survey across many different countries. Arab countries, Asian countries, Indonesia, which I guess is also considered Asia, and Africa. There is interest, but as always, it's like, show us a working prototype and you can have all our money. For now, everything is on hold regarding international commercial activities. You could say we don't want to waste our chances, because honestly, the global airship market isn't exactly overheated with offers. One company makes an offer, then a second, a third, a fourth. Everyone promises something, but no one actually does anything. The attitude is, let us build it, and everyone will come. That's the policy. In Russia, I don't publicize things much, so as not to attract trouble. I think after the exhibition in the United Arab Emirates, we'll really understand the actual level of interest. All right, well, if that's all for the questions, help the project grow. Thank you for watching and taking an interest. Share this video with someone. Tell them that here in our country, airships are being built. These guys aren't just talking. They're actually doing it and flying. Soon, you'll be able to come on your own and see how it flies, the small one for now. For the next, all demonstrations of the large airship, and the same goes for all after that. If this is interesting to you, let's get everyone around us involved. All right, another question about topping up the envelope. No, we haven't had to top it up even once in a month. The quality of the helium has only dropped by a few tenths of a %. There's no need to top it up. Okay, I admit we did top it up once, but that's all due to the material of the envelope. It stretches. After filling it, working with the ballonnet, flying it, and putting it under load, it stretched and increased in volume. We topped it up once. The envelope settled into its size, and we haven't had to add more. Everything's fine. Well, since there are no more questions, I was glad to give you this little lecture to shed some light, so to speak, on what's going on with us. Next Thursday I'll be here again, and in 2 weeks as well. Well, not next week, but the week after, come on Thursday. Bring someone along. It'll be very interesting. I'll tell you more. That's all. Thank you all. Let's get to work. Bye, everyone.
Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.